Hello adventurer, welcome to Scratch Quest. Today in our Take from Zero series, we are in digital section, and today is our day 1 of this digital section, and we'll be learning about what the digital logic subject is all about. So in this video, we will be learning what digital logic is. We will be learning what the subject offers us to teach. So what is this digital logic subject? Digital logic is a subject that teaches us about the computer from the ground level. It teaches us how it goes from a simple 0 and 1 to a full working computer. Like all of us who have used computer or even our mobile must have thought that how can this be used? How can a simple computer is run? And we learned that it is run with simple 0 and 1. It is made of 0 and 1. How does it goes from 0 and 1 to a full working computer where we can play games, we can run different software, play video games, generate images and stuff like that? Well, this is what we learn from digital logic. Digital logic teaches us the depth of a computer that we never really care about, and it teaches us what really happens inside the computer, how computer really works, and it teaches us from the very ground level, which is the machine level language 0101. So most of you have heard of this, like in movies, in any of stuff you can see there is 010101 flowing through something like that, right? So what is this 0101? Well, this is called a binary number system, where 1 means on and 0 means off. So what does 1 and 0 represent? On and off. And why? Because as you know, a computer is an electronic device. We have learned this, that computer is an electronic device that takes information, processes it and give meaningful result in our first grade, second grade, and we have been learning this definition for a long time. So we know that computer is an electronic device, and as you know, every electronic device like fridge, kettle works on electronics. But you may have noticed that we cannot talk with fridge, we cannot talk with kettle, because they don't understand human language. That's why they are called that's why, as they don't understand human language, they only understand the electronic signal, which is on and off. We can only turn on and off electronic signal. This is the language of electronic device, on and off. Now here's the problem: we have to give instruction to the computer to do certain tasks, but we cannot do certain tasks with just saying computer to on and off. How do we say? But by first representing the on by 1 and off by 0, and then using different tools like logic gates, half reader to build certain logics and help build computer and help build a compiler to make human language understandable to machine level language. So this is a very basic of what digital logic offers us to teaches us. It teaches us what computer really is. It is a machine that understands one electric signal, on and off, and we turn that on and off into a binary number language, which is called machine level language. We human don't understand machine level language, or it is really hard to understand it, and you use compiler to turn the machine level language into programming language like C, C++, or other programming language to be able to make human understand the language and be able to write the right code to give instruction to the computer. So you must have heard that computer doesn't understand human level language, and computer only understand machine level language. Yes, the machine level language we have all been hearing is 01 01 01 or 10 turn on and off. So this is what digital logic is about. Now before the ending this video, let me tell you how computer really works from the depth. So first of all, we got binary number system 0 and 1, where 0 means off and 1 means on. Where what 1 does it, 1 is also called high voltage and 0 is also called a low voltage. From 0 and 1, it is used to represent different letters, numbers accordingly, which we'll be learning later on. So after the binary number is assigned, what is done is logic gates or different tool is used to give to make different logics, so we can execute them to make calculation easier, to do complex tasks. And then when the logic is established, then comes the part of the other hardware devices like CPU, where control unit, a arithmetic logic unit and memory unit plays part in it. With the help of this combination, logic gates and CPU, CPU, ALU and memory unit, computer is run. At first, the engineering in the company makes the logic, and when I say make the logic, most people are confused in the logic gate. Like we have done many calculation where we add two number using AND gate, we using an NAND gate, we do other calculation. Most people are confused that like for example, we have to go from one application to another application. For that we make certain type of gate. People confuse that for each and every task there is each and every gate, but that's wrong, because a certain number of logic gates is made physically in the company where CPU is made, and it is using transistor. There are lot of logic gate mates in the physical hardware. We cannot make gates by ourselves after in software or something like that. Logic gate can be only be made in the hardware. I hope you understand. So in CPU, how does the calculation goes? Let me show you. For example, the input is given. So I tell a computer to type a letter apple. The input first gives to the CPU, where in CPU the input is first of all translated. Input is basically a data that is 0 and 01 01. An electric signal is sent to the CPU. So the electric signal first is given to control unit. So control unit decides, sees the binary number digits and sees where it needs where to fetch the gates, logic gates. So it goes to the memory and fetches the gates and sees where the memory is there, and then what it does is sees where the task is needed to be done and tells ALU what to do. Control unit is the brain of computer, which tells the computer what to do and where to do. Where arithmetic logic unit is a place where it does the calculation, complex calculation. Then after arithmetic logic calculation is done, if it gives some memory to the memory unit, and it gives output. So in summary, what happens is, at first you give the input, it turns into an electric signal. For example, you type apple, you need to type apple in the monitor. It first send the signal of apple, in electric signal, to the control unit. The control unit sees the binary digit apple and sees where it needs to go to the memory to catch to get the logic gate to make and to make the text apple. Then after that it goes again to central unit, and central unit decides what to do and where to do it, and it gives to arithmetic logic unit, and arithmetic logic unit does the calculation and gives the output, which is apple. which we see in our monitor. So it may seem complex as first, but as we learn, we will be learning much and more. I'm also learning with you. I have a lot of to catch up with this subject too. I hope to learn with you. I hope you understand. Yeah, that's